Okay, so look at the top here. You guys know from chapter 1 that what's the absolute value of negative 5?
5.
Yeah, it's 5, right? You see that right there? And then it says the absolute value of a positive number, so the absolute value of positive 5 is, it's also 5. Right, so if I write a couple extra examples up here. So let's say, what's the absolute value of 20? Yeah. So absolute value, what it really means, it's the distance from 0. So if I do the absolute value of negative 13, yeah, the answer is 13 because negative 13 is 13 units from 0. Okay? But now we're going to solve some equations where the variable is inside the absolute value symbols. So the first thing we got to do, step 1 here. The first step is it says get the absolute value by, good. Somebody said itself. That's good. All right, you got to do that first. Okay? And I already told you guys that how many answers are you going to get on these?
2.
You got to get 2 answers. Now, there's a couple special cases where you won't, but in general, you got to get 2 answers. So you will always create 2 equations. So you're going to write 2 in here. There's going to be 2 cases or 2 equations. All right, now the first example, let's zoom in on that. I think you guys could probably do this one in your head. So if you look at that one, absolute value of x equals 12, example 1. What number could you put in here so you get out 12? Just what number would go in there? 12, right? 12, that would be one solution, right? Because the absolute value of 12 would be 12, right? What other number could you put in right there?
Negative 12.
Yeah, you could put negative 12 in there because the absolute value of negative 12 is also 12. So there's your 2 solutions right there. So one solution is x equals 12, and the other solution, and your other solution is x equals negative 12. Does that make sense? But this first problem, that'll actually give away the technique that you're going to use to solve the rest of them. So just for a second, look at this. What I did is I took this x out of the absolute value and I wrote it right here. And I set it equal to this number right here, right? But then the second case, what I did is I took this x out of the absolute value right here and I set it equal to the negative of this number on the right-hand side, which gave me the negative 12. So that's really the process that we're going to use to solve these. So let's look at number 2. First of all, is this thing right here, is this by itself? No, what's over there with it? The 3. So how do I get rid of that 3 there? Well, it is multiplied. Right now, remember there's a little multiplication right there, right? That's 3 times the absolute value of the quantity x plus 7. Some of you guys may need your seat moved today. You can come over here and sit by me and watch this and stay over here, okay?
Sydney does.
No,
Keeps touching you.
Well, just for saying that, Noah, come on over.
What? I didn't.
Come on over.
She keeps touching me with her feet.
No,
I'm trying to pay
I don't.
attention.
Come on.
If I don't mean to.
Come on.
I didn't do anything.
Don't care.
I'm literally trying to pay attention and she.
It's this, or if you want to go down to ISS, it's up to you.
No, it's just, you won't be bothered anymore. You'll move by now.
Come on, I've been warning you guys for a couple days. So you can go there or a couple, either one of these is fine. You choose. All right, so how do I get rid of that 3, you guys? What's the opposite of multiplying by 3? Yeah, we're gonna divide by 3. So we are gonna divide this side by 3. And we're gonna divide this side by 3. And then because of that multiplication right there, now those 3's on the left, they're gonna cancel out like that. All right, 3 over 3, that's 1. So now I have the absolute value of x plus 7 equals 24 divided by 3, that's 8. Now, is this thing all by itself now, this thing? Yeah, I don't really care what's inside the absolute value. So let me erase this a little bit.
Wouldn't it just be 7x?
Let me rewrite this, hold on.
No.
So I got the absolute value of x plus 7 equals 8. And the question I asked, is this thing by itself? Yeah. I don't care what's inside of it. I'm just saying, is the absolute value the only thing on the left-hand side? And the answer to that's yes. So now listen, we're going to follow the same technique we did on that first problem. What I'm going to do is I'm going to take this thing out of here. I'm going to take the x plus 7. I'm going to take that quantity out of the absolute value, and I'm going to set it equal to 8. But then for the second case, I'm going to take the quantity x plus 7 out of the absolute value, and I'm going to set it equal to the negative of this number on the right-hand side. So that's going to look like this. So one case is going to be x plus 7 equals 8. And the other case is going to be x plus 7 equals the negative of 8. And then those are the two equations that you solve, and that'll give you both solutions. Now, what I don't want to see on people's paper is I get people to do this. They go x plus 7, absolute value x plus 7 equals 8. And they go minus 1, and then they go, okay, the answer is 7. Remember, that's going to be, you're going to get no credit for that. You got to do two cases. All right? You don't start, I don't know, why did I say minus 1 and minus 1? That was silly. This is supposed to be minus 7 and minus 7, right? And then that would give me x equals 1. But anyways, people will want to do that, right? There's going to be no credit for that. You got to set up the two cases. You got to get two solutions. So let me get this out of here. Well, let's do it. So on this one, you're going to subtract 7 on both sides. Well, the method is for the other equation is just as easy, right? We're going to subtract 7 on both sides on this one also. So on the one on the left here, those are going to cancel out. That makes 0, and you're going to get x equals 8 minus 7 is 1. But on the other one, these are going to cancel out, and you're going to get x equals, what's negative 8? Take away 7 more. Negative 15. So those are your two solutions. All right. Now, what you should do on these is you should check your answers. Now, I don't make you write out the check. Okay? You don't have to write it out. You can do it in your head, or you can just do it with a calculator. But let's check these solutions really quick. So, in the original equation. So what we're going to do is we are going to plug in, for this x right here, we're going to plug in the 1 first. So what's 1 plus 7? 8. What's the absolute value of 8? 8. And then 8 times 3? 24. So you can see that checks. Okay? Then you're going to plug in the negative 15 for the x. So we're going to put negative 15 in here. So then what is negative 15 plus 7? That's negative 8. Then you take the absolute value, that's what? What's the absolute value of negative 8? 8. And then what's 8 times 3? 24. So you can see that second solution is also good. All right? Let's keep going. So example 3. So on 3, again, the first step is you got to get this thing by itself. So So what would you guys do first to get that by itself on the left-hand side of the equal sign? Ryan?
Divide by -2.
You could, but then you'd have to divide everything by -2, meaning you would have to divide this by -2 and that by -2, which would give you a bunch of fractions. So I wouldn't recommend doing that first. What's your other option? Yeah. Good, yeah. Ethan, that's good. Subtract 13 on both sides. That'll avoid getting the fractions. So then these will cancel out, make 0. So now you got -2 times the absolute value of the quantity x plus 2 equals, on the right-hand side, you got 5, take away 13. What's that? -8, good. Now, is the thing on the, is the absolute value, again, is that alone? Is this alone over here on the left-hand side? No, what do we got to do? How do we get rid of that -2? Yeah. It's a multiplication right there, right? So the opposite of multiplying by -2 would be divide both sides by -2. So we're going to divide the left side by -2, and we're going to divide the right side by -2. And again, you should see that these cancel out and make a 1. So the -2's cancel out on the left-hand side. And now all you have on the left-hand side is the absolute value of x plus 2. Actually, let me come over here so I got some more room. I have the absolute value of x plus 2 is equal to -8 divided by -2. What kind of 4? Positive 4, right? If you got a negative divided by a negative, that's going to be a positive. Let me erase that out of there. All right, now, is this thing on the, is the absolute value all alone on one side? Yes. So now you break it down into the two cases. Now again, the two cases are you drop the absolute value, you take the quantity x plus 2 out of the absolute value and set it equal to the number on the right-hand side. And then to get the other solution, you drop the absolute value again. You take the x plus 2 out of the absolute value, and you set it equal to the negative of that number on the right-hand side. Like that. And then to solve both of these equations, it's the same step, right? We got to subtract 2 on both sides. So these cancel out, those cancel out. We get x equals 4 minus 2. 2. The other one, we get -4 minus 2 more. Good. And there's your two solutions. And then you should go back and check them. Again, just real quick. So if we go back and check them in the original here. So we're going to plug in 2 right here, right? Put 2 in there. So what is, what's 2 plus 2? 4. Absolute value of 4. That's 4. 4 times -2? -8 plus 13? -8 plus 13? 5. So it's correct. Then you try the other one, you try -6. So we're going to plug in -6 for the x. -6 plus 2. That's -4. Then take the absolute value of -4. What's the absolute value of -4? 4. Then you do 4 times the -2. -8. Plus the 13. 5 again. So both solutions are good. All right, that one checks and that one checks. All right, now we're going to get into the special cases. Okay, so let's go to example 4. So example 4 is the absolute value all by itself over here on the right-hand side. No, how do I get rid of that -8? Ryan?
Add 8.
Good. So add 8 on both sides. But now look at this. This cancels out, makes 0, so does that, right? Negative 8 plus 8 is 0. So now I got the absolute value of x plus 2 equals 0. Is the absolute value all alone now over here? Yes. Well then, I can set up my two cases then, right? So the one case is I take x plus 2 out of the absolute value and set it equal to 0. My second case is I take the quantity x plus 2 out of the absolute value again, and I set it equal to the negative of the number on the right-hand side. But what's the negative of 0?
0.
Yeah. Negative of 0 is the same thing as negative 1 times 0. That's just 0. So that's just 0 over here on the right-hand side. Well, do you see that both equations are the same? Well, then I'm only going to get one solution, right? If I subtract 2 and I subtract 2, I just get x equals negative 2. 0 take away 2 is negative 2. And so really, this other case would just give me the same answer, right? This case right here would also give me x equals negative 2. So there's only one solution for this one. I guess we could check it real quick. So if we check that one. Okay, we're putting in negative 2, right? That's our only solution. So we're putting in negative 2 right there for that x. So what's negative 2 plus 2? 0. What's the absolute value of 0? Good. Minus 8. 0 take away 8. Negative 8. So you can see it checks. So that solution is good. All right. Let's look at number 5. Sounds like I need a call on a couple of you guys to help me. So on this one, is the absolute value here all by itself, Cameron? On number 5, is that absolute value of x plus 1, is that all by itself on the left-hand side? Yes. Okay, so then I can break it down into the two cases right away, right? So somebody raise their hand, what's going to be the first case? Go ahead. Well, you got to set up the two equations first. What would the first equation look like? Damien, what do you got?
X plus 1 equals 5.
Well, it's actually, you take this thing out, so you take x plus 1, that quantity out of the absolute value, and set it equal to the number on the right-hand side, right? And then the second case, what would that one be, Damien? Yep. Yeah, it would be positive 5. Because you would take x plus 1 out of the absolute value, and you would set it equal to the negative of the number on the right-hand side, right? But the negative of negative 5 would be just 5, right? The negative of negative 5 is just 5. And then you would solve both of these. So you would just subtract 1 on both sides. Those would cancel out, make 0. So on the case on the left, you would get negative 5, take away 1 more. That's negative 6. And the other one, you would get x equals 5, take away 1 would be 4. All right, well, now we got to check these. So if we check these, the first one we're going to plug in is, we're going to put in negative 6 right here. So what is negative 6 plus 1? Negative 5. What's the absolute value of negative 5? That's 5. Does 5 equal negative 5? No. That means that solution right there is no good. Let's try the other one. So now we're going to plug in the 4 for the x. So we're going to put 4 in for x. So inside here now we got 4 plus 1. What's that? DeJuan, that's good. Yeah, 4 plus 1 is 5. What's the absolute value of 5? 5. Does 5 equal negative 5? No. So that solution is no good either. So cross that one out. So what do you write? Good. So there's no solution. So there's no solution. Or you could write this thing, right? Either way. Now, is there a way, looking at that original problem, is there a way to see that there's going to be no solution? Look at this thing. Let's highlight this thing. Look at this original problem right here. Tell me, how could you look at that and see that there's no solution? Oop. Ethan, what do you got?
Doesn't have like the plus or minus or number or whatever?
No, that's not it. That's a good try, though. Ryan?
Because there's only a negative on the right.
Yeah. Can the absolute value ever equal a negative? So look at, if you get this thing all, now here's the key to this. So I want you to be able to just look at it and tell that there's no solution. If you don't notice it and you just happen to work out the whole problem like we did, if you get down to here and you check these answers, neither one is going to work and you're going to figure out there's no solution. But what I'd rather have you do is just look at this thing. Once you get this thing all by itself, if that's ever equal to a negative number, then you know there's no solution right away. What's up, Ryan?
Negative for questions like these, we still have to show like the whole.
No, if you can notice that, well, you'd have to get it by itself first, but once you got it by itself, you could just write no solution. So let's make that clear one more time. So again, if you have the absolute value here all by itself, and it's equal to a negative number, that can't happen, right? Because the absolute value is never negative. So if you see that happen after you get the absolute value all by itself, then you can just write no solution. So let's look at number 6 over here. What's the first step on number 6? Is this thing over here, is this absolute value thing all by itself?
No.
Now, how do we get rid of the 3? Ryan?
Subtract it.
Good. So now we subtract 3 on both sides. These cancel out over here. Now we have the absolute value of x plus 4 equals 0 take away 3 is negative 3. Is the absolute value over here all by itself? Yes. Is it equal to a negative number?
Yeah.
So what do you know?
It's no solution.
Good. That's good, Ryan. Yeah. As soon as you see the absolute value all by itself and you see that negative number over here on the right-hand side or on the other side of the equal sign, then you know right away you can just write no solution. But if you didn't notice it and you went and worked out the whole problem, you'd find that the 2 solutions you got neither one of them work. All right, so then we just got one to go, right? And we got to fill in this blank right here too. This blank right here says an absolute value can never ever be negative. Good. All right, and then we got to work out this word problem. So this word problem, and then we're done. All right, let me tell you, you guys can get the answer. But you guys, I'm going to show you how to get the 2 answers for this problem really quickly. And then from there, we'll talk about how you write an absolute value equation to represent that problem. I don't think I can zoom in any better. You guys are going to have to read it on your sheet there. You want to make a support beam for a building. It's got to be 3.5 meters long. And it can be up to 3 millimeters too long or 3 millimeters too short. And it'll still fit. Okay? So a millimeter is about the width of your pencil lead. So basically, picture 3 pencil lead widths. That's how much too long the beam can be or how much too short the beam can be, and it'll still fit properly, okay? So The only issue with this problem that I don't like is that they gave they gave this number for how long, how much too long or how much too short the beam can be in millimeters, and they gave you the length of the beam in meters. So that means you're going to have to put them into the same units first. So let's do that real quick. So let me show you how to do a unit conversion. So we've got 3.5 meters times, and we want to change this into millimeters. Yeah, I don't want to have to move any more people today, but I will if I have to. And these seats can become permanent. All right, so if it's meters, 3.5 meters, I want to put meters on the bottom right here, and I want to put millimeters on the top. And the reason I do that is because now the meters will cancel out like that. So do you guys know 1 meter, how many millimeters is that? Does anybody remember? 1 meter has how many millimeters in it? What about, do you remember 1 meter has how many centimeters? Well, we're going metric to metric. That's why they wanted us to convert to the metric, because it should be easier to do this, but we don't remember them. Centi, that's like a century, right? That's the prefix, centi. So centimeter, how many centimeters are in a meter then?
1,000.
Centimeters, well, that's good. It's 1,000 for millimeters. You got that part right. There's 1,000 of these. All right, I was trying to get you to centimeters first. 1 meter, which is about 3 feet, okay, a little bit bigger than 3 feet, that has 100 centimeters. Each centimeter is about the width of your fingernail. But then each 1 meter, again, which is a little bit bigger than 3 feet, that has 1,000 millimeters. Okay, each millimeter is about the width of your pencil lead. But anyways, if we go ahead and multiply straight across the top and straight across the bottom here, we're going to get 3,500. I'm going to leave that comma out of there. It's going to be 3,500 millimeters. Okay, if we multiply by 1,000, we just move this decimal place 3 places to the right. All right, so we're just moving that decimal point 3 places to the right. We'll get 3,500 millimeters. Okay, now we can do the problem. So it says that if we were going to solve for x here, the longest that this beam could be where it would still fit, it says it can be 3 millimeters too long. So what would that be? If the beam is 3,500 millimeters, what would be 3 millimeters longer than that? Just add 3 to it. What would it be? Come on, we're just doing 3,500 millimeters plus 3 millimeters. What's that?
3,530.
Yeah. So the longest that beam could be where it would still fit would be 3,503 millimeters. All right. And the shortest it could be where it would still fit, we would just subtract 3 millimeters. So what's 3,500 minus 3? Good, yeah. Thank you, Dawn. 3,497 millimeters. So we've already answered the question, okay? Does it kind of make sense? This beam has got to be 3,500 millimeters. It could be 3 millimeters too long, which would give you 3,503, or it could be 3 millimeters too short and it would still fit. And that would be 3,497 millimeters. So those are your 2 solutions. We already have them, okay? But the other part of this question says, I'm kind of working this backwards for you guys so you can see it. The other part of this thing says that we have to write an absolute value equation. All right, so we got to write an absolute value equation that's going to give us these two solutions. So what that would look like, you'd want the length of the beam. So the length of the beam we'll call x. You want the difference of that and the 3,500 millimeters. You want the absolute value of that difference to equal the number that represents how much too long or how much too short it could be. Does that make sense that would work? So let me see if I can say that again without messing it up. So this would be the length of your beam. You want the difference of that and the 3,500 millimeters that the beam is supposed to be. You want the absolute value of that difference to equal how much too long or how much too short the beam could be. So it could be 3 millimeters too long or 3 millimeters too short, and it would still fit. Now, can you see if you solve that, you're going to get these two answers over here? If I just write it down real quick, you would do what? You would take this thing out of here and set it equal to 3, right? And then you would take this thing out of here again, and you would set it equal to the negative of that number on the right-hand side. Can you see that's going to give me those two solutions? Again, I'm going real fast with that, but I think you guys can see that on this one right here, you would add 3,500 on both sides, right? So if you add 3,500 on both sides right here, that's going to give you 3,503, which is this one. All right? And then if you solve this other one right here really quickly, you would add 3,500 on both sides. And there you would have a negative 3 plus 3,500, and that would give you the 3,497. Okay, so I kind of worked the problem backwards for you guys, because I wanted you to see that the two answers were pretty simple. All you had to do was add 3 and subtract 3. But the second part of the solution was you got to write this absolute value equation. All right? So if you want a hint for how to set that up, you always want to do this where this number over here outside of the absolute value, that's going to be the number that represents like how much too big or how much too short it can be. The 3 is how much too long it can be, or the 3 millimeters is how much